All right, this is problem number 3, and problem number 3 has 3 different parts. The radius r, height h, and volume v of a right circular cylinder are related by the equation v equals pi r squared h. A little bit of an insult. You kind of knew that already, I hope. So volume of the cylinder is pi r squared h. First part, how is dv dt related to dh dt? And notice in part A, they're going to hold r constant. All right, so let's begin with part A. So we'll write our equation. We know volume equals pi r squared h. We'll take the derivative with respect to time on both sides of the equation. So the derivative with respect to time, the derivative with respect to time. On the left side, there's not a whole lot we can do. dv dt is dv dt. So we've got that. On the right side, we have a derivative, but we notice first, pi is certainly a constant, and they're holding r a constant. So this whole quantity, pi r squared, is a constant connected with multiplication. And so we know pi r squared is just going to factor through, just like any other constant connected with multiplication. And now the derivative of h is dh dt. That completes part A. Okay. Let's move on to part B. Let's see if we can squeeze it in right here. We'll start with the same formula. Volume equals pi r squared h. We'll take the derivative with respect to time. So the derivative with respect to time, the derivative with respect to time. And again, on the left side, there's very little we can do. dv dt. And on the right side, pi is a constant. H is a constant. Again, both connect with multiplication. So both of those factor through. We have this pi, we have this h, and now the derivative of r squared. Power rule, bring down the power. Make it one less. But don't forget your chain rule. The derivative of the inside is that r is the inside, and the derivative of the inside is dr dt. We can simplify that just a little bit. So we get dv dt equals, we've got a 2, got a pi, rh, or hr, I guess it doesn't matter a whole lot. I think generally it's rh dr dt. And that completes part B. Now, let's take a look at part C. We're kind of compare and contrast here. Here we had part A, pi r squared dh dt, when r was a constant. Part B, when h is a constant, 2 pi r h dr dt. And now let's attempt part C. So part C, start with our volume equation yet again. Wait, what was that equation? Oh, we should know that. Volume is pi r squared h. Let's take the derivative, both sides. Take the derivative with respect to time. It's a related rates problem. So with respect to time, left side, let's see what we get. Looks like dv dt, no big deal. Right side, r is a variable. H is a variable. Connected with multiplication, we have a product rule this time. Two different variables connected with multiplication. When we take the derivative, that's a product rule. And look at the pi, a constant connected with multiplication. The pi is going to factor through. So let's put the pi here first. We'll put a big parenthesis because it's going to factor through. And now we have the derivative of this part, this r squared h. It's a product, so the product rule tells us 1 d2, the derivative of h is dh dt, plus, and we've got a 2, which is our h. And now the derivative of r squared, we bring down the power, we make it 1 less, and the derivative of the inside, again, because that was r squared, so we brought down the power, made it 1 less, and the derivative of the inside gives us this dr dt. Maybe, oops, I'll close my big parenthesis. Maybe now we want to distribute and kind of look up above as we're doing this. So dv dt equals, we've got pi r squared dh dt. Oh, look, that looks familiar. Plus, and again, I'm distributing the pi. So I took it times the first quantity. I'll take it times the second quantity. So distributing the pi, I get 2. I get a pi I get an R and an H, and I get a dr dt. So very interesting. When they're both variables, what just happened? We got the sum of part A plus part B. So part A, when R was a constant, part B, H is a constant. When they're both, when neither is a constant, when they're both variables, we get the sum of both. That completes our problem.